Hello students, welcome back to your favorite YouTube channel, Tomaxang Tutorial. Myself, Kishan Kulung, and today we are ready to go for a new topic, and that is Mendeleev's Periodic Law. Okay, we are ready to go for Mendeleev's Periodic Law in this video. We have already completed Doberiener's Law of Triad, Newlands Law of Octaves, and Lothair-Mayer's Curve in our previous videos. Please find the link below in the description and watch those videos. Okay, now let's talk about Mendeleev's Periodic Law. But before that, I request you all to give few minutes of your precious time and watch this video till the end. Okay, I assure you I'll make you understand everything about Mendeleev's Periodic Law. Okay, let's begin. Dmitry Mendeleev was his real name. Okay, Dmitry Mendeleev was his full name, and he was a Russian scientist. Okay, and I want you to know that during his time almost 63 elements were known to mankind. Please remember this. During the time of Dmitry Mendeleev, almost 63 elements were known to mankind. Okay, please remember this. I hope you will remember. Now, to know the properties of each of these 63 elements, what did Mendeleev do? He reacted each of these elements with hydrogen and oxygen. Okay, he reacted each of these elements with hydrogen and oxygen to determine their chemical properties. Okay, now please remember that hydrogen and oxygen were among the 63 elements, isn't it? Hydrogen and oxygen were a part of the 63 elements. So that means Dmitry Mendeleev reacted 61 elements with hydrogen and oxygen to determine their chemical properties. Are you getting me? Yes. Now the question arises, why did he choose hydrogen and oxygen specifically? Why did not he choose another element instead of hydrogen and oxygen? Isn't it? That is the question which pops up in our mind, isn't it? Now the answer to that is, number one, hydrogen and oxygen were readily available. Are you getting me? Hydrogen and oxygen were readily available, means hydrogen and oxygen were found readily. Okay, number two, number two, hydrogen and oxygen are very reactive. Very reactive. Hydrogen and oxygen are very reactive elements. Okay, hydrogen and oxygen are very reactive elements. So it is good to choose reactive elements to react with some other element, isn't it? And the next point is, hydrogen and oxygen reacts with most of the elements to form compounds. Did you understand this? Why did Mendeleev choose hydrogen and oxygen to react with the rest of the elements to determine their chemical properties? Is number one, hydrogen and oxygen were readily available. Hydrogen and oxygen are very reactive elements, and hydrogen and oxygen are very reactive and they react with most of the elements to form compounds. And when an element reacts with another element to form compound, then only we can know their chemical properties, isn't it? So Dmitry Mendeleev reacted hydrogen and oxygen with the rest of the elements known at that time to determine their chemical properties. Okay, now when he knew the chemical properties of almost all the elements, he wrote them in different cards. Okay, he wrote them in different cards. That means he took 63 different cards. 1, 2, 3, 4, there are 63 cards. I cannot draw all 63 cards here, isn't it? That means there are many cards in between them. 1, 2, 3, 4, 5, 6, 7, 8, 63. There are 63 different cards, okay, for 63 different elements. Now, suppose this is calcium, okay. Suppose this card is for calcium. Mendeleev wrote all the physical and chemical properties of calcium in this card. And suppose this is sodium. He wrote all the physical and chemical properties of sodium in this card. Similarly, if this is lithium, he wrote all the physical and chemical properties of lithium in this card. And suppose this is fluorine, he wrote all the physical and chemical properties of fluorine in this card. Good? Okay. There were 63 elements known at that time. He took 63 different cards and wrote the properties of each of the elements in those 63 cards. I hope you got this. Okay, after that, what did he do is he arranged this card in the increasing order of their atomic masses. Okay, let me write that. He means who? Mendeleev, okay? He means Mendeleev. He arranged the cards in the increasing order of their atomic weights. I hope you understood this, isn't it? There are 63 different elements, means 63 different elements have 63 different atomic masses, isn't it? Because each element has their own atomic mass, means 63 different elements means 63 different atomic masses. So the element having the lowest atomic mass is kept in the front, and the higher than the higher. I hope you got this. Okay, in the ascending order. Very, very simple, isn't it? He arranged the cards in the increasing order of their atomic masses. The element having the greatest atomic mass was placed at the last, and the element having the smallest atomic mass was placed at the first. Okay? I hope you got this. And when he finished arranging the card in order of their atomic masses, increasing atomic masses, surprisingly he saw some pattern. Okay, he found some pattern in this arrangement, and he put forward his law called Mendeleev's Periodic Law. I hope you got this. This is called Mendeleev's Periodic Law. Okay, Mendeleev's Periodic Law. Let me write the law for you. After finishing the arrangement of the card, he saw something surprising property. He saw something pattern in the arrangement, and then he put forward this law. Okay, and the law states that physical and chemical properties of elements are the periodic function of their atomic masses. This is what his law says. This is called Mendeleev's Periodic Law. This is very, very simple law. Okay, on the basis of this law, Mendeleev prepared this table. This Mendeleev's periodic table. This is called Mendeleev's periodic table, but not the original version. Okay, this is the modified version, a little bit modified version, but it is Mendeleev's periodic table. Okay, now let me give you the outline sketch of this Mendeleev's periodic table. There are 8 columns, 8 vertical columns known as groups. 1, 2, 3, 4, 5, 6, 7, 8, isn't it? There are 8 vertical columns known as groups. These vertical columns are called groups. Okay, and each group subdivided into group A and group B. Subgroup A and subgroup B. Subgroup A and subgroup B. Okay, each group from 1 to 7. Each group from 1 to 7 is divided into subgroup A and subgroup B. And group A is not divided in that way. You can see there is no A and B here. I hope you are getting me. And there are 7 horizontal rows in this table. You can see 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. There are 7 horizontal rows in this table, and these 7 horizontal rows are called periods. Okay, vertical columns are called groups, and there are 8 groups in Mendeleev's periodic table, and there are 7 horizontal rows called periods in Mendeleev's periodic table. Okay, now let us get back to the law. Physical and chemical properties of the elements are the periodic function. Periodic function. What does the term periodic mean? Periodic means which reoccur after a fixed interval, isn't it? The term periodic means which repeats itself after a fixed interval. It's called periodic, isn't it? So, physical and chemical properties are periodic. Periodic means which repeats itself. Physical and chemical properties repeats itself when the elements are arranged in atomic masses, means in the increasing order of their atomic masses. I hope you got this. Let me explain you again. When the elements are arranged in the increasing order of their atomic masses, elements having the same physical and chemical properties repeats itself after a fixed interval. Got my point? Yes, I hope so. Let me give you the example from the table itself. Elements having the same physical and chemical properties repeats itself after a fixed gap, isn't it? Lithium. Let's take for example lithium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And the 15th element here is sodium. Okay. This sodium has the same physical and chemical properties as lithium. Lithium is an alkali metal. Lithium is the most electropositive element. Lithium has the lithium has big atomic volume. You can say lithium atomic volume of lithium is very large. Sodium also the same thing. So, sodium is also electropositive element. Sodium also alkali metal, isn't it? Sodium is also an alkali metal, and so the atomic volume of sodium is also big. Okay. Similarly, lithium has the greatest tendency to lose electron. Sodium has the greatest tendency to lose electron. Okay, after lithium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again comes the potassium. I am just forgetting about group 8, okay? For now, just this is for example, isn't it? I am just giving an example. After a fixed, if you take up to group 7 only, after a fixed interval of 15 columns, then comes potassium, then comes rubidium, then comes cesium, then comes francium. All these elements have the same similar physical and chemical properties. Are you getting me? Yes. Elements falling on the same group has same physical and chemical properties. Don't believe me? Check out this. Fluorine, chlorine, bromine, iodine, astatine. Okay. All these are electronegative elements. They all belong to the same group. All have the similar characteristics, isn't it? So, according to Mendeleev's periodic law, when the elements are arranged in increasing order of their atomic masses, elements having similar characteristics, means elements having similar physical and chemical properties, repeats after fixed interval. Repeats itself after a fixed interval, means they fall under the same group. Got my point? Yes. Now let us write some merits first. Merits of Mendeleev's periodic table. Okay. Merits. Merits means the advantages, isn't it? What are the advantages of Mendeleev's periodic table? Merits of Mendeleev's, this is Mendeleev's periodic table. Number one, atomic weights of various elements were corrected which were initially initially calculated incorrect. Okay. Atomic weights of various elements. Atomic weights of various elements were corrected which were initially calculated incorrect. Mendeleev's periodic table helped to correct the atomic weights of various elements which were initially incorrect. Okay. In the olden days, the earlier scientists gave different atomic weights, and when the Mendeleev's periodic table came into existence, this Mendeleev's periodic table corrected the atomic weights of various elements which were initially incorrect. Okay. Number two is considered as the biggest achievement of Mendeleev's periodic table, and that is Mendeleev left some gaps for the elements which were yet to be discovered. Are you getting me? Mendeleev left some gaps for the elements which were yet to be discovered. For example, during the time of Mendeleev, there was no element here. Okay, just below silicon, there was no element here, and Mendeleev wrote Eka silicon. He gave the term Eka silicon. Are you getting me? Just below the silicon, there was no element, and Mendeleev was so sure that there is an element here, but which is not yet discovered. And he was so sure that this element will be discovered in the near future. Okay, and so he left this gap for that undiscovered element. He did not arrange the elements like Newlands. Newlands arranged all the elements in a random way, not in a random way. He did not leave any gap for the undiscovered elements, isn't it? But Mendeleev, the beauty of this table is he left the gap for the undiscovered element. He was so sure that some element does exist in this box, but this is not yet discovered, but this will be definitely be discovered in the near future. And he said, name this element as Eka silicon. Okay, Eka silicon. Let me write here, Eka silicon. Not only this, he predicted the physical and chemical properties of this Eka silicon also. Okay, and later on, when the element was really discovered, this was called germanium, and this germanium was placed with the symbol Ge, and the properties of this germanium actually matched with the Eka silicon, okay, which Mendeleev predicted before the discovery of germanium, because during the time of Mendeleev, germanium was not discovered yet. So he named Eka silicon. Eka is a Sanskrit word which means one, okay, which means one, which means silicon means the element having one property means one. Element having the similar property with silicon will be in this group, isn't it? Because in the same group lies the element of having the similar properties. So this germanium has the property of Eka silicon. Okay, I hope you got this. Namely, I'm giving the names, okay? Namely, Eka silicon, Eka silicon. Eka silicon means germanium, okay? Another is Eka aluminium. Eka aluminium. Eka aluminium. Eka aluminium is gallium. Just below the aluminium, there was no element during the time of Mendeleev, and Mendeleev left this gap for the undiscovered element, okay? He did not put this IN here or TI here. He just left this gap as it is. And he was so firm in his belief that he said, the element is yet to be discovered, but I will tell all the properties of this element now. And he named the undiscovered element as Eka aluminium, and he left the gap. Later on, the element was discovered here, and the name of the element is gallium, and the symbol is Ga. So the property of Ga actually matches with the property of Eka aluminium. Correct match, okay? The property of Ga, gallium, matches with the property of aluminium, because aluminium has also valency 3, gallium also has valency 3, and all these are same type of elements, okay? Now let's move further. And Eka boron, and Eka boron, Eka boron. Okay, now let us discuss about the demerits of Mendeleev's periodic table, okay? Demerits, the disadvantages. Number 1, position of isotopes. Position of isotopes. Okay, you know that Mendeleev's periodic law says that elements are arranged in the increasing order of the atomic masses, isn't it? So each box should have different atomic masses, isn't it? This element has different atomic mass, and this element has different atomic mass, this element has different atomic mass, this element has different atomic mass. Are you getting me? Mendeleev arranged the elements in such a way that each element having different atomic mass should be placed in a different place. Got my point? Yes, that is exactly what he says. So isotopes means, suppose let us talk about hydrogen, okay? Hydrogen has 3 isotopes, 1,1, H12, H13. What does this mean? Atomic number 1, all of this is hydrogen. Atomic number is 1. All of these are hydrogen, okay? But their mass number is 1, here the mass number is 2, and here the mass number is 3. What is mass number? Mass number is nothing but the sum of protons plus the neutrons, isn't it? When you add the number of protons and neutrons, you get the mass number. And from the mass number, we get the atomic mass, isn't it? So these 3 are the same element, hydrogen, having the same atomic number but the different mass number, which means they have different atomic masses. So according to Mendeleev's periodic law, these 3 different isotopes should have 3 different places, isn't it? Got my point? Because they have different masses, so they should have been placed in 3 different places. Why only one place? So position of isotopes is not justified. Position of isotopes is not justified. Okay, this is one example. There are so many examples. Let me take the example of carbon. Carbon, we have C612, C614. C6, atomic number 6, this is carbon. Both the atoms are carbon, but the mass number of carbon in this case is 12 and the mass number of carbon in this case is 14, which means the number of protons plus the number of neutrons is 12, number of protons plus number of neutrons is 14. These two are the same element carbon having different atomic masses. So they should have different places. Why only one place here? Are you getting my point? And another example is, let's say chlorine. Chlorine, C17, 36, 35, C17, 37, isn't it? C17, 17, this means, oh, this is chlorine, isn't it? Cl17, 35, Cl17, 37. Mass number is written on the superscript and subscript is the atomic number. Okay, Cl17 is the atomic number of chlorine is 17. This is also chlorine, atomic number 17. Their mass numbers are different, isn't it? 35 and 37. So their atomic masses are also different. If their mass number is different, then definitely their atomic masses will also be different, because atomic mass comes from atomic number. Okay, so these two isotopes have different atomic masses, and according to Mendeleev's periodic law, atoms having different atomic masses should be placed differently in the increasing order, isn't it? So chlorine should have been placed in 2 different places. Where is chlorine? Oh, chlorine should be here in the halogens group, isn't it? Chlorine should have been placed in the 2 groups. Why only one? The question arises. So position of position of isotopes is not given in the Mendeleev's periodic table. Number 2, defects of Mendeleev periodic table is number 2. Elements having greater mass number, greater atomic mass, what is this? Atomic mass are written before elements having smaller atomic mass. And this is the violation of his own law, isn't it? His law says elements should be arranged in such a way, that the atomic mass should be constantly increasing, isn't it? Elements should be arranged in the increasing order of their atomic mass, isn't it? So elements having the smaller atomic mass should come first, and then the elements having the greater mass comes, isn't it? So what did I write here? Elements having greater atomic mass are written before elements having smaller atomic mass. See here, cobalt 58.94, isn't it? And nickel 58.69. Among these two, which is heavier, 94 or 69? 58 is same, but 0.94 is greater or 0.69 is greater? Obviously 0.94 is greater. So nickel should be written here and cobalt should be written later, isn't it? Are you getting my point? Nickel should be in the front and cobalt should be after nickel. But what Mendeleev did is to make the properties same, to arrange the property of the elements in the same group, he wrote nickel letter and cobalt in the front. So he violated his own law. Not only that, in this case also, let me write noble gases. This is for the noble gases, okay? Noble gases. Why do we call noble gas? Noble gas is actually noble gas was not discovered, or noble gas was unknown during the time of Mendeleev. During the time of Mendeleev, noble gases was undiscovered. Okay, now let me tell you what is noble gas. Actually, what does noble gas means? Noble gas means inert gases. Noble gas means inert gases. Why inert? Because they have the stable electronic configuration and they are so unreactive that they do not react with any other element. Okay, are you getting my point? Yes. Noble gases are also called inert gases because the outermost shell, the valence shell, is stable. Means they have the stable electronic configuration. So they do not want to lose electron or they do not want to gain electron. They do not want to share electron. Okay. So this is the stable electronic configuration. When they have the stable electronic configuration, they do not want to react with the other elements. Got my point? So noble gases do not react with other elements, so they are called noble gases or inert gases. And what are they? They are helium, neon, argon, krypton, xenon, radon. Okay, these are the noble gases. Helium, neon, group. I started from the group. Okay, let me write from here. Helium, neon, argon, krypton, xenon and radon. These are the noble gases. So these noble gases have zero reactivity. They are also called zeroth group element. In the modern periodic table, you will find in the 18th group. These noble gases do not react with any other element, so they are called inert gases or noble gases. Okay, because they have the stable electronic configuration. Now, the atomic mass of argon is 39.9. Okay, let me write here 39.9. The atomic mass of argon is 39.9, and after argon comes the next element is potassium, isn't it? The atomic weight of potassium is 39.10. Are you getting my point? The atomic weight of argon is 39.9 and the atomic weight of potassium is 39.10. So according to Mendeleev's periodic table, the elements having lower atomic weight should come first and the atom having greater atomic weight should come later, isn't it? The atoms having lower atomic weight should come first and the elements having greater atomic weight should come later. But here argon 39.9, which is greater than 39.10, is in the front, and comes the potassium, which is the violation of Mendeleev's periodic law. Okay, and the third demerit is position of hydrogen. Position of hydrogen. Okay, the position of hydrogen is not justified, isn't it? Hydrogen behaves like a metal. It sometimes loses electron and becomes electropositive H+ ion, so it is placed in the alkali group. But hydrogen actually is non-metal, so in some periodic table it is seen to be placed above halogen. Okay, above halogens. Hydrogen is a gas and is a non-metal, so it should not have been placed here. But even today in the modern periodic table also, the position of hydrogen is not yet justified. Okay, I hope you understood. Thank you so much for watching this video, and stay happy, stay safe, stay blessed, and don't forget to subscribe and click on the bell icon. to get notifications for more video uploads. Thank you so much.